All right, this is the 7-8 notes, solving systems of equations by substitution. So our goal here, we have two equations and we want to find the point in which they intersect, so where they have the same x and y value. So what we can do is we can use substitution to isolate one of the variables so that we can solve for one. So we have y equals 2x and 3x plus y equals 10. So we know that y is the same as 2x. So what we can do is we can take 2x and substitute it into the second equation for y. So we can replace this y right here in the 3x plus y equals 10 with 2x. Okay, so you can see now we have 3x plus 2x equals 10. Now we have an equation in one variable and we can solve for x. So 3x plus 2x is 5x here. That equals 10. Divide by 5, you get x equals 2. So we know that both of these equations will have the same x value when x is equal to 2. So now that we know x is equal to 2, we can pick either the first equation or the second equation, because remember, we're trying to figure out when they're both the same. So they're both the same at x equals 2, so either one will work. So I just picked the top one, y equals 2x, because it's easier. Substitute in x equals 2, you get 2 times 2, so y equals 4. So the solution to this system of equations is 2, 4. So if we were to graph both of these linear equations, they would both have the same they would both intersect at 2, 4. All right, so here are two more examples. The first example is very similar to the one that I went through just now, so I'm not going to talk through it, but you can, pause this and look through my solution. The second one is a little bit different, so I will talk through this one real quick. So we have the two equations, x equals y minus 5 and 3x plus 2y equals 3. So it already isolates a variable for us. It already tells us that x is the same as y minus 5. So I can substitute in y minus 5 for x in the second equation. So that's exactly what I did. I have 3 times y minus 5. Remember, that used to be x, but now it's y minus 5. Plus 2y equals 3. So let's distribute 3y minus 15 plus 2y equals 3, and then you can continue to solve and you will get y equals 18/5. So now that we know the value of y, where both of those equations will be the same, we can substitute that in. So I just picked the first equation because it's just a lot easier to substitute variables in, or values in. So x equals y minus 5, let's substitute y for 18/5, and you get x equals negative 7/5. So their intersection point is negative 7/5, 18/5. Okay, here, zoom in on this a little bit. Here's two more examples. This time it doesn't have the variable isolated for you, so you actually have to make sure you solve for either x or y. Either one will work, you just have to isolate one or the other. So I just picked the second equation here, x minus 2y equals 6, because it's really easy to just get x alone. You just add 2y to both sides. So we know that x is the same as 2y plus 6. So I'm going to use 2y plus 6 and substitute it in for x in the top equation here. Okay, so we have, instead of 5x, we now have 5 times the quantity 2y plus 6, plus 3y equals 17. Again, distributive property, you get 10y plus 30 here. And then if you continue to solve, you'll get y equals negative 1. Now that you know y equals negative 1, you can either pick the top or the bottom equation, substitute it in, and solve for your x value. So I just picked the bottom equation. Again, it's just a little bit easier than the top one, less steps involved. So I substituted in negative 1 for y, and once I simplify, I get x equals 4. So the solution is 4, negative 1. The second example is the same thing, same strategy as the first one, so I'll just leave it here. You can look through it, pause it if you want, but I'm not going to talk through it. Alright, so these two, they get a little bit harder. They're a little bit more involved, but it's the same concept. So we have 7x minus 6y equals negative 30 and x minus 4y equals negative 20. So again, we need to isolate one of the variables so that we can use it to substitute. So I just picked the second equation and I'm going to solve it for x. So we have x is equal to 4y minus 20. So now I can use 4y minus 20 and substitute it in for the value of x in the first equation. So that's exactly what I did here. And then I solved for y and I got y equals 5. Used y equals 5, substituted in to the either equation works, remember, but I just used the second one, substituted it in, got x equals 0. So the solution is 0, 5. Okay, similar strategy for the second example here. So again, I suggest trying it on your own first, and then you can come back and look at the solution here. All right, and it looks like that's it.